Hello, my name is Billy Deutsch, and this is my presentation for the Alabama Productivity Center for the internship I had this spring of 2018 at Mercedes-Benz in Vance, Alabama. So a little bit about this presentation. First go over me, and then a little bit about Mercedes, and then the projects I worked on, and then I'll do a quick summary. So this is me. I'm originally from Nashville, Tennessee. I am a junior at the University of Alabama. I'm majoring in mechanical engineering and I'm minoring in German, and I am planning on graduating in the spring of 2019. And I'd like to continue working in the automotive industry after I graduate if possible. Here's a picture of my mentor, Andreas Richter. He is from Sindelfingen in Germany, and he's worked at Mercedes for his entire working career, so he has a very vested interest in Mercedes, and he loved his job very much, and I enjoyed working with him a lot. So Mercedes in Vance, Alabama is actually MBUSI, which stands for Mercedes-Benz US International. They are the producers of the C-Class line of their cars in Plant 1. And then in Plant 2, they make the GLE and GLS SUVs and also the GLE Coupe. And they're the only that plant is the only location in the entire world where they make those SUVs and that specific coupe. And in total, they export $1 billion worth of cars every year. So they make a huge economic impact for Alabama and the Tuscaloosa area. So the department I worked in at Mercedes was called series planning. So they're basically responsible for all the offline pre-assembly areas where there's these parts that are really complicated that have a bunch of different parts, and they pre-assemble them and make them ready to be put on the car once they get to the actual online line. So this involves kitting and sequencing. There's these boxes where they grab all the different parts, say like the center console has like all these different bits that they pack this into this like organized box to be easily assembled onto the line. And pre-assembly is like screwing in bolts and screws into, well, like I said, like really complicated parts so that it's much faster once it gets to the actual line. And all of these parts in the entire plant are organized on something called an 80-20 rack, or they just call them racks, but it's these big aluminum rolling storage things with these rollers on it that help the parts roll down. And I have a picture here next. Here I'm going to go over the projects that I worked on, which was including the 80-20 racks, but here's a kind of visualization of how I initially felt, which was a little lost, but thankfully I quickly learned how everything operated thanks to my mentor. So yeah, here's a picture of an 80-20 rack. And 80-20 is like the name of the aluminum that is used in these racks. And you can see those little black lines on the rack, which are the rollers, which allow those plastic bends to roll down the rack. And at the very top, there's a return rack where the parts go back to the back, and continually they have this, they operate by like a just in sequence or just in time. So there's always constantly parts being put into these racks by people on like forklifts and these things called like tuggers, just like people constantly putting these plastic bins into these racks. So yeah, it organizes a specific area. You can put all the different parts that go to a certain specific part of the car in a certain area, and yeah, like I said, makes a constant flow of parts easy because the parts roll in. And so part of what I worked on was helping to design these racks, deciding where parts would go in the racks that would make the most sense, and all these different parts. Some of them have also like multiple colors, so you kind of have to account for that, like what colors go together and whatnot. And all these parts have numbers associated with them, and I'll go back to that. Part of what I also did was created all the labels for them. So every single part had a part number, and then also needed two labels, one for the front of the rack and one for the back of the rack. And these numbers change constantly, and they have this program that I had to go in and check whether it had changed or not. And also I organized all of the part numbers in a nice Excel document, and I did that with my mentor and kind of organized it so it made sense. There's about like 12 or 10 ish, like they're called KSP cells, or the kitting, sequencing, and pre-assembly. These areas that are offline. There's like 10 of those that he was responsible for, that I helped him with, that I organized all the part numbers for those areas so that it'd be easy to print off these labels. I also helped make these labels by printing them out and cutting them and attaching them to the actual racks. And then additionally, on top of that, I did a time study on how long it took for team members to screw in bolts into the subwoofer, so that could later be attached to the speakers in the car. And I also did some other random screws and bolts and made a large Excel spreadsheet and did like a bunch of different trials with the stopwatch and averaged those times, and created a standardized time for how long someone would have to screw in each of these bolts, depending on like how long they were and how the actual screw went in. And then near the end of my internship, a project I worked on was to help recreate this table. So it's a pretty complicated table with a bunch of different parts on it, and it's for the brake and fuel line. So when it needs to be pre-assembled, there has to be a bunch of clips that are put on it so the brake and fuel line can go together. Plus, they have to screw some attaching like elements to it so it can be attached to the car later. So part of or what I did is I took dimensions of every single bit of this table. So all those like little plastic bits you see and the metal, and I modeled all of those parts in SolidWorks, and I made all the dimensions in this really long PowerPoint presentation that I sent to my mentor and the guys in the KVP shop, which is the shop where they are actually going to build this. So they're going to use my drawings to make this table, and I sent them all the 3D models, and they were going to 3D print all those plastic bits so that, well, they needed an additional table because this table was just for training, and they need another one for the actual production. So, and this one was made in Germany, and apparently they didn't have the drawings for it, so they needed somebody to recreate this table, and that was my job. And yeah, you can kind of see an example of the SolidWorks modeling that I did. I took all the dimensions of it, modeled it in SolidWorks, and then I made a PowerPoint with all the different dimensions on it and showed them that so that they could, use that later to make this table that they needed. And I did that for 31. There was 31 total plastic bits, and then the table additionally, which was made of that same 80-20 aluminum material. And as far as total impacts using the impact calculator, I calculated that I had a total impact of $42,500, And that was including all the time I spent on designing racks, printing out labels, doing the time study, updating the Excel spreadsheet, and also modeling all those parts in SolidWorks, and just making sure that that was all good. And also the countless times I helped my mentor do random things in the KSP cells to make sure they were the way they were supposed to be set up. I helped with the alignment of all the racks and the taping, and yeah, just making sure every single rack was accurate and had the right labels and was in the correct position. And um, for the modeling part, I estimated I worked about 30 minutes per part for 31 parts, so that was 930 minutes or 15 and a half hours I spent just alone on the modeling. That helped them not have to guess the dimensions, because all they had to do was click print on their 3D printer. And uh, yeah, and I organized all their part numbers in an Excel document that they can use in the future. That's really straightforward. So in summary, my name is Billy Deutsch. I'm a junior mechanical engineering student at the University of Alabama. I worked this semester at Mercedes-Benz US International in Vance, Alabama at Plant 2 in the series planning department. I worked on multiple projects throughout the semester for the KSP cells with, like I said, labels and racks and modeling in SolidWorks. And for total impacts, I created the time study and multiple Excel spreadsheets that they can use, and that huge PowerPoint with all the different models in it that they were going to use to make that new table. So thank you.